Hey everybody, I got a couple articles that I just kind of want to go through. One of them, imagine this, it's rush hour traffic, but instead of cars on the freeway, it's satellites up in near space orbit. And right now, Earth's orbit is more crowded than it's ever been. We have thousands upon thousands of satellites, many from mega networks like Starlink that are up there, and they're packed into a relatively thin layer of space, low orbit, just above the planet. Scientists are now warning of something surprising. If satellite operators suddenly lost control, say because there was a massive solar storm, a major space collision could happen in less than 3 days, 2.8 days. Thus the title of this podcast, in only 2.8 days. A few years ago, about 2018, that was estimated that we'd have about 4 months before we'd have to gain control to stop impacts of satellites. Today, because of the sheer volume that's up there, it's only 2.8 days. Why does that matter? Here's why. Satellites constantly dodge each other. In fact, near misses happen about every 20 seconds up there. Normally, computers and humans guide them safely out of the way, so they do miss each other. But solar storms, those are those huge eruptions from the sun, and we've talked about those lately, can heat up Earth's upper atmosphere, scramble satellite navigation, and knock out communications between Earth and the satellites. If that happens across many satellites at once, nobody can steer them. And in space, one crash just isn't one crash. One crash then sparkles off and hits another one, causes another one, causes another one, causes another one, and you get a ripple effect going through. When satellites collide, they explode to thousands of fast-moving fragments. Those fragments will smash into other satellites. That triggers that chain reaction, that ripple effect that could make parts of orbit unstable for years, possibly. To be clear, it's not a prediction that disaster is coming this week. Okay, we're not talking that. It's just a warning that has come out in a paper that I'll link to over on Patreon here, down below, and you'll be able to get that. If you're on YouTube, you can go over to my Patreon Easy Astronomy site and get the link there to the article. It's just, again, a warning. This is what could happen. Space above our planet has become so crowded, it's so fragile, and it's surprisingly dependent on everything working perfectly all the time. And let's be truthful. What works perfectly all the time, especially when humans are involved? Nothing. The takeaway, we're relying more than ever on space for our internet, our GPS, our weather, our communications. But we're also running out of room, and the margin for error continues to grow smaller and smaller. Okay? It means that we're going to have to start maybe looking at that space and regulating it a little bit more, and thinking about what's in our best interest in the long term, not just in the short term. There's an article here to the 12 Days to Disaster Earth Orbit. It's an article that came out. Just kind of wanted to go through it. Something to think about. I know when I'm out observing in the desert, especially early in the evening, we've seen this a couple times, just starlight and other series of satellites just coming across the sky. And then as the sun goes down, they're usually reflecting off the sun. They're kind of like an old, what we called an iridium flare. Those were iridium satellites. They were wonderful. They'd happen all throughout the night. And it was just right when they were in the right orbit, the reflection of the sunlight off of them would cause them to flare up. Well, these are in a chain, so as the sun strikes them, both in twilight and then in twilight in the morning, the reflection lights them up, but it's a big chain, and you can see that chain. So we just need to really think about, and I think that's the point of this article, how do we want that space to look, and what would happen if we had a major solar storm that knocked out communications, knocked out our ability to navigate these satellites, and we had that ripple effect, that chain reaction that just caused satellites to be knocked out, and all those fragments out there, we probably couldn't get through it for a while until we figured out how to safely navigate that. You don't want to send humans on a craft, on a rocket through that, and have that stuff shred the rocket and then destroy and kill the crew. It's just, that's not a good thing. So again, read the article, see what you think about it. Today, another bold theory has come out, and I'll reference the article down below about how Earth's companion, the moon, in the night sky came to be. In the past, we think one theory has it was a colossal smash up with a planetary body called, I believe, Thera, and but rather through that terrifying explosive ejection from the Earth itself, they collided and was ejected out. That's one of those mind-bending ideas that shakes up have long-held assumptions in planetary science that the moon was created by a Mars-type impact onto the Earth that threw up the ejecta, and the gravity of the Earth coalesced it and then formed the moon. Scientists have for a long time wrestled with how the moon, the origins of it, how it came to be. It goes all the way back to the late 19th century. One early idea proposed by George Darwin, the son of Charles Darwin, suggested the moon was simply spun off from a rapidly rotating Earth. But that notion struggled with the laws of physics, especially conserving angular momentum. So for many years, the giant impact hypothesis has become the dominant story. A Mars-sized object named Theia slammed into young Earth, blasting debris into orbit, where it eventually clumped together, coalesced together to form the moon that we have today. Here's the twist with that. When Apollo astronauts brought back moon rocks, scientists were surprised that isotopes in those moon rocks matched the Earth so closely that it didn't look like the moon was made from some foreign impact. Okay, the discovery reopened up that old question: how did could the moon have come from Earth after all? Enter the explosive ejection model, a fresh take that revives aspects of earlier fission idea, but with a dramatic new mechanism. Inside a giant rock hitting the Earth from the outside, this model suggests that energy built up deep inside the Earth, possibly near the core mantle boundary. And that could have driven a sudden powerful explosion that blasted with enough force to hurl out massive amounts of the Earth's mantle and crust into orbit, where eventually coalesced to become the moon. In this theory, Earth's internal dynamics, including how heat and gravitational energy move through the planet's depths, played a key role in this. Over millions of years, the stored energy could have reached a critical point, triggering this major ejection event. Okay, let's see. Just kind of going through my notes here really quick. In this theory, Earth's internal dynamics, okay, kind of force that to happen. What makes the idea intriguing is how it naturally explains the moon's composition, especially why lunar rocks brought back from the Apollo missions are so similar to Earth's mantles and the isotopes found there, without needing to evoke a separate impact theory like Theia coming into the Earth and ejecting it out. It's a reminder that even our closest cosmic neighbor still holds secrets waiting to be uncovered, and that closest neighbor is our moon. There's still secrets, there's still science to find behind that, and questions to answer through science. That's what makes it fascinating. It's a theory. Theories need to gather evidence. The evidence then either confirms or denies the theory in science. So we have a theory now, and they think with the isotopes, maybe it kind of matches. Let's see where this one takes off. It's an interesting idea that the Earth swung out the moon from a catalysmic event that happened as it was blown off. Just kind of interesting. 2 articles. Think about it, and remember, keep looking up. Keep having a clear sky, and when it's clear, look up, see what you can see up there, make a connection to it, make a connection with each other, and have clear skies in your personal life. Have a great evening.